In this video, we're going to find the arc length of r equals 3e to the 2 theta, where theta is between 0 and 1. And we're going to use the fact that we know that arc length for a polar curve from alpha to beta is the square root of r squared plus dr d theta squared. This comes from our arc length formula for parametric equations, and then once simplified for polar equations, simplifies to this. So L is, we already know alpha and beta are 0 to 1. And then we're going to have square root of 3e to the 2 theta squared plus, we need the derivative of this, so dr d theta is going to be 3e to the 2 theta times 2, or 6e to the 2 theta. So 6e to the 2 theta squared d theta. Alright, so integral from 0 to 1. Let's square both these and see what happens. Squaring this gives us 9e to the 4 theta, because 3 squared is 9. E to the 2 theta squared, well, and we're raising something to an exponent, and then that's being raised to an exponent, they multiply. Same here. So plus 36 e to the 4 theta d theta equals, those are going to add up. We now have like terms. So 0 to 1, square root of 45 e to the 4 theta d theta. So we have some perfect squares in here that we can simplify this a little bit. 0 to 1. 45 could be split into 9 times 5. So that means I can pull a 3 out of the radical, or a square root of 9. And also, this is a perfect square. If I take the square root of this, same as raising it to the 1/2 power, that's e to the 2 theta, and then I'm just left with square root of 5 d theta. Now what I like to do is I like to pull any constants out of my integral. So 0 to 1. I'm going to pull the 3 square root of 5 out, and it's just now the antiderivative of e to the 2 theta d theta. That's a square root of 5 there. And what I might want to do is use a u substitution for, let that be 2 theta. Then du is 2 d theta. So I see that I have the d theta there, but I'm going to need a 2 there, which means I'm going to need to multiply by a 1/2 out here. So those in blue is part of my u substitution. And so now we can make the substitution. We have 3 square root of 5 over 2 on the outside. And now it's just e to the u du, a very simple integral. Now the other thing I'm going to do is I'm going to change my limits. These are theta values. I want them to be u values. The conversion is, I got to take whatever theta is, multiply it by 2. So 0 times 2 is still 0. 1 times 2 is 2. And now I don't have to substitute back. So I've got 3 rad 5 over 2 times e to the u, which is the antiderivative of e, and I got to incorporate my limits 0 to 2. So final answer, we got 3 rad 5 over 2. Now what I'll see a lot is people will do the e squared and just leave it. But don't do that, because e to the 0 is not 0, e to the 0 is 1. So there's our final answer. Probably we would go ahead and rewrite that as 1. So 3 square root of 5 over 2 times e squared minus 1 is our exact answer to that definite integral. So that's the length of that curve.